Today we're going to look at verifying identities, which is very similar to simplifying expressions. So in the first half of the lesson, we talked about how to simplify expressions. We had three main strategies there: that we would factor sometimes. It's a good thing to do when we can, but it's not something we expect to do every time. Then we used substitutions from our identity list. And then we changed our functions into all sines and cosines instead of using all 6 trig functions. We limited it down to just sines and cosines, and that sometimes allowed things to cancel out. For verifying an identity, we're going to use those same 3 strategies, but an identity has an equal sign. So we have one more step that we can do with it and take advantage of the fact that it's an equation. So we can do anything we would do to an equation. So we can add, subtract, multiply, divide on both sides if that's helpful. If there's fractions or proportions, we can multiply so that we don't have fractions anymore as well. So we have kind of an added advantage of having that equal sign and being able to work with an equation. Another thing that's a little bit nicer about identities and expressions is one of the hard things for students in an expression and simplifying is when is it good enough? So I talked about how if we can get it down to being just one single term, that's probably good enough. But if there's more than one part to it, sometimes that's still as good as we can get it. Sometimes we could do more. So it can be a little bit tricky for students to know when is it actually done. With verifying, it's a lot more clear when you're done. The goal of verifying an equation is to show that the 2 sides are either exactly the same, like 1 equals 1, sine equals sine, exactly the same, or to turn it into one of our identities. Since our identities at the beginning of the notes are things we know to be true, and we didn't prove them, but hopefully you'll believe me that they are true identities, then if we can turn our equation into one of those, then it must be true. So these are a little bit more clear-cut as to when we're done with them. So our first strategy is to factor, but we don't do that very often. We're not going to do that here because we don't have any adding or subtracting. So then we look for substitutions we can make. One group of the identities where we do substitutions is when we have this negative theta or negative x or negative angle. Okay? So we can look here for that. We only have identities dealing with sine, cosine, and tangent for that. So we don't have any substitutions we can make. So what we're going to do then is the third strategy of turn this thing into sines and cosines. Cotangent is equal to cosine over sine. And since it was a negative theta, it will be negative theta for both of them. I'm going to do the same thing on the other side and have a negative, and cotangent is cosine over sine. Now if we check back to that identity list, these negative angle identities are there. On that identity list, it says that the cosine of negative theta is equal to just the cosine of theta. That for cosine, the negative really doesn't make a difference. And it says that the sine of negative theta is the negative sine of theta. So those are identities that are on the front of the notes that you don't need to memorize. Those will be provided to you when we come to the test on this stuff next week. By making those 2 substitutions, the 2 sides of this equation are now exactly the same. They both have a negative, they both have a cosine over a sine. When the 2 sides of the equation are exactly the same, that shows that this equation must be true. So we say, yep, we're done. There is not a final answer to these questions per se, as in something to put like a box around. Okay? The process is what matters. There are often even different ways you could do things and still get to having it proven in the end. So the process is what matters, not like a final answer. With the simplifying problems that we did in the first half of lessons, those have a final answer. The final answer is as clean as we can make that thing. But in the verifying problems, our goal is to just make the 2 sides of the equation the same. And when they're the same, then we can say that we've done it. So this one again, we have one of those negative angles, but it's for secant, and we don't have a rule about secant in our identity list. So we want to rewrite this in terms of sines and cosines. Which one is secant the reciprocal of? Cosine. So we're going to write this as 1 over cosine. And anytime that our theta is negative, it has to still be negative. We're just changing the secant into 1 over cosine. Then on our identity list, it tells us that the cosine of negative theta is equal to just the cosine of theta. And in making that substitution, the two sides of this equation exactly match now, so it must be true. Here we have a fraction. The first thing I'm going to do is multiply both sides of the equation by the denominator cosecant of x so that I don't have fractions anymore. I don't particularly like fractions, and I find a lot of students don't also. So we're going to multiply both sides by that denominator. Multiplying the fraction by cosecant, we'll just cancel it to leave us the top is cotangent squared. On the other side, we're going to distribute this. Cosecant times cosecant is cosecant squared. And then minus sine x cosecant x. This is something that we can do because this is an equation. So the types of problems that we looked at in the previous half of the lesson where we just had expressions, there was no equal sign, we couldn't do this there because there's no both sides. Okay, so we can only do this multiplication because we're multiplying both sides of an equation. If there's no equal sign and it's a fraction, you just have to deal with it being a fraction. Okay, so if it's just the expression that we're simplifying like the last one, we just have to work with the fractions. If it's an equation, we can get rid of them. Now, there are many different ways to do these problems. There is a fairly quick end to this problem that I can see, but it is likely not something that you would see. So the journey I'm going to take us on is not the quickest way to solve this problem, but I'm going to do this because this is kind of how I would emphasize to you as starting to do these. Follow our strategies. Just kind of go step by step through the strategies, and we'll get to a conclusion in the end. But I just want you to know sometimes there are faster ways, and as you become more comfortable with these, you might start to see some of those shortcuts in here, and that's fine to do that then. But I'm not going to take it because it's not something that I can necessarily train you to see. You'll just kind of learn to see it over time maybe. So our next strategy is to change this thing into sines and cosines. So when I change this into sines and cosines, cotangent is cosine over sine. Since the cotangent was squared, the cosine and the sine will both be squared. Cosecant is the reciprocal of sine. Sine is just sine. I like to write it over 1 so that everything's a fraction. And cosecant is the reciprocal of sine. So remember, when it comes to the test on this, you don't need to know any of those identities that are printed on the front, but you do need to know how the different functions are related to each other in terms of being able to change them into cosines and sines. A goal of changing them into cosines and sines is that so that hopefully something will cancel. And that does happen for us here. In this multiplication, sine over 1 times 1 over sine, those signs cancel each other out. They cancel to just make 1. Okay, they don't cancel to totally disappear. It's like doing 2 over 1 times 1/2. 2 times 1/2 is 1. It's not just gone. Okay, so they cancel and leave a 1 in its place. So we started the problem by multiplying by a denominator to get rid of fractions, and then now we just ended up with fractions again. So we're going to multiply by our denominator, sine squared x, over on the left-hand side, those sine squareds will cancel. So I just get cosine squared x. Over on the right-hand side, I need to distribute. I get 1 minus sine squared x. We're very close to the end now. They said an identity is done when the two sides are exactly the same, or if you can make it match one of the identities that's on the front of the sheet, because those identities on the front of the sheet are definitely true. So if we can turn this into one of those, then it must be true also. So one of those identities on the front of the sheet that I look at when I see a lot of squareds and ones is sine squared plus cosine squared equals 1. So if I can turn our equation into that, then it must be true. And we can turn this into that by adding the sine squared to both sides. And once we have that identity, we can say, yep, we've done it. Same strategies as the first lesson. Change into sines and cosines and substitute. But because this is also an equation, we can take advantage of multiplying by the same thing on both sides or adding or subtracting the same thing to both sides. All right, so our strategies. One strategy is factor. There's nothing in this that we can factor. Another strategy is look for substitutions that we can make. So on that identity list, one of our identities says that the secant squared of x is equal to 1 plus the tangent squared x.
Can I go to the bathroom?
Leave your phone and take the bath. So because secant squared x is equal to 1 plus tangent squared,
What's the pass?
where
No.
you put your phone.
This is the pass. Okay.
I'm going to take that 1 plus tangent squared, and I'm going to replace it with a secant squared. I'm not going to make any other changes on that stuff. Okay, one step at a time. So one of our strategies is look for things that are in those identities and swap them out. So 1 plus tangent squared is equal to secant squared, so I'm going to swap it out. When I do that, I now have a secant on the top of the fraction, and I have a secant on the bottom of the fraction. Because this is all multiplication in this fraction, we can cancel. If this was cosine plus secant, you cannot cancel. Okay? Many of you will want to. You cannot cancel when there is adding or subtracting inside of a fraction. That will happen on your homework. But you'll have a problem like this that has a plus in there. Can't cancel then. But because this is all multiplying, division undoes multiplying. So then we can cancel. So we can cancel out one of these secants, which leaves us with cosine over just a plain secant is equal to cosine squared. The two sides of this don't exactly match yet, so we're not done yet. I'm going to multiply both sides by secant. So on the left side, it cancels that denominator, and I just get cosine. On the right-hand side, nothing cancels. So I'm going to use our strategy of change it into sines and cosines. So cosine will just be cosine, but it's squared. And secant is 1 over cosine. And We now have cosine on the top and bottom, so we can cancel out one of them. So that leaves us with cosine equals cosine, which is true.
How do you move from having cosine squared x and secant x to the division 4?
I left a cosine squared x, a cosine squared x. I just put it over 1, because we can always divide by 1. Secant is the reciprocal of cosine, so I change that secant into a 1 over cosine. And then I can cancel those cosines. In this one, we have what is called a proportion. A fraction equals a fraction. The way we solve proportions is cross-multiplying. So we're going to multiply on the diagonals here. When I multiply sine times sine, it will be squared. So sine squared x. When we multiply those other two things, they have parts to them. When we multiply things with parts, we need to distribute or FOIL. So pass out the 1, and I get 1 plus cosine x. And I pass out the negative cosine x, and I get negative cosine x minus cosine times cosine is cosine squared. When we do that, something nice happened. In the middle here, I have a plus cosine minus cosine. Cosine minus cosine is 0. And this is starting to look a whole lot like one of our identities. That identity is in the order of sine squared plus cosine squared equals 1. So if we can make our equation look like that, then we're done. And we can do that by adding the cosine squared to both sides. Again, there's not a final answer. There are different ways to do this problem that could result in a different final line. It would still have to be something true, but there's different ways to do this problem that we might have ended up having something like sine equals sine, or having something like 1 equals 1. So the last line itself isn't as important as the work it takes to get there. So I hesitate to say this because so many of you hated them so much, but these are kind of like geometry proofs. It doesn't necessarily matter how it ends, it matters how we get to the end. It's the process that matters, which means in the homework and on the test, no work, you're not actually doing the problem, right? We need the work to show how the problem is done, because the work is really what matters. We have one more example to do, and as is often the case, our last example is going to be our lengthiest example, just so that we're all aware going into this problem. This has the most stuff go on in it.
Stuff.
Okay, our strategies are always the same. So a lot of times students are like, I don't even know where to start. Start with the strategies. Okay? Look for substitutions we could possibly make. Since these are equations, we can get rid of fractions by multiplying both sides by something and changing into sines and cosines. Those are the keys. Looking for substitutions, changing into sines and cosines, and then the problems that have an equal sign, working with the equation and multiplying both sides by something. So since this one's a fraction equals a fraction, we can do that cross-multiplying again. So I'm going to multiply secant times cosine squared. And for the other diagonal, we have parts, so we're going to need to do the distributing. So I'm going to multiply 1 through. That gives secant x minus tangent x. And I'm going to multiply the sine through. So it's sine x secant x and minus sine x tangent x. For multiplying stuff with parts, we need to make sure that we distribute or FOIL through. When we did that in the last problem, something really nice happened, that two of the terms ended up being exactly the same. We had a cosine minus a cosine, it could go away. Here, it doesn't look like anything matches. So when it doesn't look like anything matches and we have all different trig functions represented here, one way to try to get things to match up is to turn them all into sines and cosines. So we're going to go through and turn each of these into a fraction of sines and cosines. So secant is 1 over cosine. Cosine squared will stay cosine squared. I like to put it over 1. You don't have to. I just want everything to be a fraction when I'm done. So it's all the same. Secant is 1 over cosine. Tangent is sine over cosine. I have a sine to put over 1. The secant is 1 over cosine. The sine to put over 1. And the tangent is sine over cosine.
2 minutes. Not enough space. It's like a train tracks.
One nice thing that can happen when we do this is that anytime we have a multiplication, we can look to see if something matches that can be canceled. So in our multiplication pairs over on the left, we have two fractions that are multiplied. There's a cosine on the bottom, a cosine on the top. So we can cancel out one of those cosines, and that whole side just turns into cosine. Then we've got a single fraction by itself that just has to stay. Another single fraction by itself, that has to stay. Then we have a multiplication. But on the top is a sine, and on the bottom is a cosine, and those don't cancel each other. So we're going to just multiply those fractions together. When we multiply, we just put together the tops, put together the bottoms. And then we have another multiplying. We've got a sine on top, another sine on top, and a cosine on bottom. So nothing cancels, but we're going to multiply them together. Sine and sine make sine squared, and cosine on the bottom. So there wasn't as much canceling as we may have hoped for. But something nice did happen.
Sine and cosine.
In the middle of this, we now have a minus sine over cosine and a plus sine over cosine. Minus something plus something is 0. So yeah, cosine, 1 over cosine, that whole middle becomes 0. So I have the minus sine squared over cosine. We're going to get rid of the fractions here by multiplying the whole equation by cosine, because that's the denominator. Cosine times cosine will give me cosine squared. When I distribute this cosine, I will get 1 minus sine squared, which by adding a sine squared to both sides turns into the most popular identity. I know these problems are tricky. I know they are. I don't want to give the impression that these things are easy. They're not. They're not supposed to be easy. They're supposed to be hard. Follow your strategies. Take it step by step. Okay? Change into sines and cosines. Look for substitutions. And if there's an equal sign in it, then multiply both sides to get rid of fractions. But you can only do that if there's an equal sign in your problem. Okay, otherwise substitutions and changing into sines and cosines. So the homework is not what it says here. It's whatever it says on your paper, which is a whole lot of odds. So 29 to 37 odd and 41 to 51 odd. I'm not stupid. I hope you don't think I'm stupid. I am not stupid. I assigned all odds on purpose because I want you to be able to check your work. That doesn't mean I want you to open your book to the back page and write down what it says on the back page. Okay? I want you to be able to check your work. Okay? These problems are hard, and being able to check your work or look for a hint is my goal in assigning the odds. So please take advantage of the help that I'm giving you, but don't take advantage of me by cheating. Okay?